All right, let's get back to it. Here's some references. Those are kind of after a few other things. Let's talk about algorithms. Let's talk about functions after that. And then, yeah, passing by reference and passing by values right after references. Okay, algorithms. So algorithms are introduced alongside vectors. We can say, you know what, let's create a function to display the items in our vector. And I'll add a few other things to our vector too. Let's see, nuclear throne, GTA San Andreas, comma, what else? What have I been playing? Into the Gungeon. What else? Sure, some console games. How about Super Mario Bros? How about Donkey Kong Country? Yeah, that's probably good enough. Okay, so I'm going to create a function. And a function has to be declared outside of any other function. My function is going to be return type of void. It's going to accept one parameter, and that parameter is going to be a vector of string objects. We'll call it given vec for given vector. And we'll say for int I equal to 0. I is less than given vec dot size. Add 1 to I. And that's the easy for loop. And we'll just say cout. I always like numbering my lists. Okay. So I'm going to send it my favorite games, and it's going to output all of my favorite games. We can say cout your list. Okay. And let's call display fave games and see what that gives us. 2, no, 2. And here's my list. So with algorithms, I can say favegames.sort, and this should sort them by name. Now when I run this, I'm going to get an error, and the reason is that sort doesn't exist because I haven't called the include function algorithm. If I run it now, okay, sort might be named something else, capital S. Damn. Okay. Let me look it up in the book real quick. So we'll go, what is it, chapter 4, I believe, using vectors. Using iterators. Aha. Erase, insert, there's algorithms. Random shuffle. Okay. Scores begin, scores end. Aha, that's probably what I'm missing. Probably missing that scores begin, comma, scores end. So I got to give it two iterators. The iterators are favegames.begin and favegames.end. Oh man, I'm so close. Let's see, how do I get to that window I just had open? It's gone forever. Perfect. That's funny. Here. Sort. Oh, so maybe it's not favegames.sort, it's just sort. There we go. 2 in 2. Okay, so I sort them, and then I need to display them again. Two in 2. And here it is sorted. Dishonored first, Donkey Kong, sorted by first letter. Or, you know, alphabetically. Okay, let's put this book back in here. Might need that again. Full screen this. And let's do random shuffle. And display again. And there it is in a random order. There you go. All right, that's algorithms. What else do we have? Hey, we knocked out functions, parameters, and return types. So there's several return types. I've covered this a billion times. I could return a string, random. Let's call this a random game. And we'll take random index. We'll take a vector of strings named given vec. Again, because of scope, given vec only exists inside this function. So I can create a different given vec, and it only exists within this different function. And we can return. What are we going to return? We're going to return given vec of random number modulus given vec dot size. Let's go ahead and see if that works. So cout, here's a random game from my list of faves. Play it. And we'll give it fave games. And we'll see what it does. Donkey Kong Country, and if I play this again, Grand Theft Auto San Andreas. Different every time. So what's happening here is I'm calling the function random index, and I'm sending it fave games, which only exists inside int main. So once this function, it only exists inside this function. It's not a global vector. And so we send it fave games, and we're creating a copy of fave games named givenvec. And then we say return givenvec, and then here's the index, a number between 0 and whatever the size of givenvec is. And so it returns a single string inside givenvec. And that's how return types work. That's how parameters work. All right, what else can we talk about? References, passing by reference, passing by value. So a reference is a nickname for a variable. And we could say that string ampersand, we'll say r underscore a game is equal to fave games of 3. So that might be more complicated. Maybe it'd be simpler to say int reference r underscore some number is equal to don't we have an ship damage, right? And then we could see out r some number is equal to r some number. And it would work just like calling either one of these variables. So if I called r some number, that'd be fine. If I called ship damage, that'd be fine. If I edited it, they would edit each other. So r some number equals 46 because that's what ship damage is after we add 1 to it way up there at the beginning. Doesn't that seem like forever ago? Let's make sure we're still recording, shall we? We are. Good. So that's a reference. And then we get into passing by reference, which means instead of creating a copy of fave games and using givenvec and returning givenvec, we would just say that givenvec is a reference to fave games, and then we would be editing and getting data from the original vector, not from the copy of the vector. So let's talk passing by reference. Passing by value is what we do kind of by default. So this is passing by value. It means it's creating a copy. But passing by reference, let's say we wanted to do, let's do the exact same thing. We'll say string RefIndex is equal to a vector strings. This is a reference named refvector. Now we'll just call it givenvec. That's fine. It's not going to hurt anything. And we'll return givenvec of random number. I'll just copy this. So let's see if RefIndex works as well. And you're like, why does this matter? Who cares? And the answer is that with a large vector, we don't have to copy all that into a new memory spot. We're just using the original. So this is much faster, much more performant. So RefIndex, fave games, cout equal to RefIndex fave games endline. Oh no. No match for operator. So we need to dereference given vec. Because given vec is a reference. Maybe. Let's see if that fixes it. No. So my assumption is that I need to do that. No? Line 49. Yeah, it's definitely an issue there. Oh, man. So this should just return a string. If I totally cheated and it wasn't random at all, I could just return given vec of 1. Or I could try dereferencing given vec. Or I could try creating these guys around that. And it just does not like that. Did I forget to add references somewhere? No, I don't think you need to add references. String RefIndex, vector string reference, given vec. Let's look at that book. Passing references to alter arguments. Good swap. Int x, int y. Doesn't return anything. Constant references, returning references. See, I don't really want to return a reference. This would be returning a reference string ampersand. Vector string there, vec, return, vec of I. See, I don't have to do anything crazy. It's just not happy with something else that I'm doing. There's no include statements crazy. IOStream, string, and vector. I built mine the same way. RefIndex, vector, string, given vec, return, given vec of 1. So it's just returning a string. You should totally be my friend. 158. Ah, this returns a string. So maybe this one's just freaking out. That's fine. I can handle that. So, RefIndex fave games equals stalker. And then we could actually make it genuinely random by copying this. And run it. And Super Mario Bros. So that's passing by reference, and it means that I don't have to make a copy of whatever vector I give it. I just use the one that is there. References are very nice. Okay, pointers. So pointers involve messing with memory. Pointers point to a memory address. Which is where the address of operator comes in. So we can say, here's a pointer to a float named p underscore distance. And we can assign it to nothing. We can put this asterisk on either side. This is a pointer. And then we can say p underscore distance is equal to the address of ship distance. Where was that? Distance from home. So p distance is equal to the address of distance from home, and then we simply say cout p underscore distance is pointing at p underscore distance. And what's that going to show? That's going to show the memory address. No, leave me alone, thank you. Jeez. Let's see. The value that p dist is pointing to is dereference operator p underscore distance. So let's run that. Maybe get some errors. No, always nice when it works the way I want. So pdist is pointing at that memory address. The value that pdist is pointing to is 3.14. We can do the same thing that we did with references to pointers. Let's go ahead and just say cout pointer index fave games is equal to pointer index fave games. Fave games? That's not what I want. Alright, so let's go ahead and build pointer index fave games. It's going to return a string too. So it's still called passing by reference, even when you're using pointers. We'll return a string again. Pointer index, we'll take a vector string objects, and it's a pointer to given vec. I can see something already. A pointer is just a memory address, so we can't just give it given vec, because given vec is a vector, not a memory address. So we're going to have to give the address of fave games in order for this to work. So we give it the address of fave games, and it returns yes, dereferenced given vec of, let's just test it, make sure it works. Run. Woohoo. And there, pointer index, nuclear throne. So let's make it random. Here we go, all the stuff in here. Command C, Command V, and run it. Oh no. Aha, there's that other. I knew I would need this. You guys saw me use it. There you go. GTA San Andreas. Run again. Half-Life 2. Okay, so that's pointers. If you need to know more about that, they're in Chapter 7. There is more to do with that, to be sure. But address of, making pointers, dereferencing those pointers, that's going to be the important part. So, classes, constructors, and classes within constructors. I suppose under classes we should also have, like, data members. And we should also have member functions in addition to constructors. And then classes within classes, we'll get to that next. Okay, classes are variables that we create. So let's Control X, come on down to our, you want to build it above our functions? Sure, why not? So above our global variables, above our functions, we'll build our classes. So we'll build a class called, what do you guys want to call it? Orc. Okay, and this orc should have a name, right? We'll go ahead and make the orc's name private. And it'll be a string, im_name. And we can't assign them here. And we'll do a int im_damage. And then under public, we'll have our constructor. And our constructor has to be named exactly the same. And this is where we'll assign a string given name is equal to, what's a good orc name? Grok. And then a int given damage is equal to 2. Not a lot. And then you do it however you like. One simple way to do it, one that makes sense and we've been using a lot, is we say that im_name is equal to given name. And we say that im_damage is equal to given damage. And then just to make sure that our constructor is working, we can say a new orc has been created. So these guys are data members. This is a constructor. And we can have battle cry, cout. My name is im_name. And prepare. Let's do it. You killed my father. Prepare to die. Love it. Cout. I'll just have a little debug statement. Stabs with im_damage. Damage. Love it. This is going to be fun. So come down here and we will create our orc.